Okay, this is 7.4 trigonometric functions of any angle, and objective 1 asks us to find the exact value of the trig function for any angle. So we're not talking about 45 degrees, 60, or 90. What we are talking about now is any angle in different locations around the circle. So this could be 220 degrees, etc. So how do we do that? Well, sine is defined as b over r. I like to change that to y because you guys are used to seeing x comma y. Okay, so sine goes with y. Cosine, the a is x, so it's x over the radius. Sine is y over the radius. And tangent is y over x. And the reason why is because, remember, tangent is defined as sine over cosine. So I'm going to go ahead and erase the denominator there and rewrite it, just to make it more neat. Okay, so cosecant, because it's its reciprocal function of sine, is r over y. Secant is r over x. And cotangent is x over y. So once again, these are letting us have the ability to find points all around the rotation around the circle where the radius is not 1. Okay, so once again, sine y over r, cosine x over r, tangent y over x. I like to say sine-er, cosec-er. Cosec-er sounds like a wannabe Sam's Club, and shinier sounds like you're trying to say shiny but didn't quite come out right. So hopefully that helps you memorize what's what. There's a diagram down on the bottom of the page. Once again, let's turn that to x and y's because you're so used to using that. So you have some point there, and what happens is now we're able to find the values of the 6 trigonometric functions. Okay, so here's an example. It says find the exact value of each of the 6 trig functions of a positive angle theta if 4, negative 3 is the point on the terminal side. So let's get rid of that point and let's use another one. So the first things first is I would draw it because I want to know where I'm at. So 3, negative 2 is in the 4th quadrant and is right here. So I just drew that for you. So if I would continue drawing this, to draw the triangle, the base is always connected with the x-axis. So I'm going to say that again. The base is always connected with the x-axis. All right, so once we have that guy drawn out, remember we've gone 3 units over in the x direction and 2 down. So right now I'm going to ignore the negative sign just temporarily, and I'm going to go ahead and draw that triangle out. So what do we have? We had a 3 here, a 2 here. We need to find the hypotenuse, or the radius, if you will. And how do we do that? We use Pythagorean theorem. So 3 squared plus 2 squared equals r squared. 9 plus 4 is 13. So r equals the square root of 13. Okay, I'm going to go ahead and put that there. I'm going to put the negative sign in front of 2, just so I can keep track of it. Now it says use the definition to find the remaining trig functions. All right, so sine of this angle is defined as opposite over hypotenuse. So the angle is the one that's created with the x-axis. So we can do opposite over hypotenuse. The opposite side is negative 2. The hypotenuse is square root of 13. So if I rationalize this, I get negative 2 radical 13 over 13. And it's negative, okay? Its reciprocal function is cosecant. So we're going to flip that guy over, so I get radical 13 over 2, and it's negative. Okay, moving on. Cosine. So cosine is adjacent over hypotenuse. Okay, if I look at the angle, the adjacent side is 3, and the hypotenuse is 13. And once again, this is going to be positive. And I'm just looking at that a moment, guys. Okay, yeah, that's right. Sorry, just was checking on something really quick. Okay, so this becomes 3 radical 13 over 13. And secant is its reciprocal function, so we just go ahead and flip it over, and we're good. And finally, tangent. Tangent is defined as opposite over adjacent, so you do the same thing. Where's the angle? What's the opposite side? It's -2. What is the adjacent side? It is 3. So that one's done. And then finally, cotangent theta is -3 over 2. All right, a really quick check to make sure we got the right signs for all of the trig function is I'm going to show you the mnemonic device. We're going to learn it anyways in this section. It's all students take calc. That means A stands for all, S stands for sine, T stands for tangent, and C stands for cosine. These tell you what angles, or what trig functions, excuse me, are positive in what quadrant. So in quadrant 1, everybody's positive. In quadrant 2, sine and its reciprocal function cosecant is positive. In quadrant 3, tangent and cotangent are positive. In quadrant 4, cosine and secant are positive. The other functions besides quadrant 1 are negative. So for instance, in quadrant 2, if I have cosine, that's negative because the only thing that's positive in quadrant 2 is sine and cosecant. Okay, so that's your quick check. We'll go over that again in a little bit. All right, unit circle. So the unit circle has a radius of 1, hence the word unit. Unit means per 1. If you go to the grocery store, they will have on the tag the per unit price. So that's per 1 of something. All right. So the unit circle, we're going to learn it in a little bit, probably in the next section. But just for now, I want you to know the 4 key values. So I'm going to go ahead and put them up here. So here's 0 degrees, 90 degrees, 180, and then 270, and then circling back to 360 degrees. Okay, so these values are 1, 0, 0, 1, -1, 0, and 0, -1. If you're wondering where did I get those values, it's because the radius is 1. So at those points, your radius is 1, therefore giving you the 0s and 1. Okay, so for part A, it says find the exact value of each of the 6 trig functions. Really quick, we have to think that cosine goes with x, remember cos xer, and sine goes with y. Okay, so on the unit circle, because sine was y over r, and r, the radius, is now 1, sine is just y. And cosine was defined as x over r, and because r is 1, it's now just x. Okay, so we can find the 6 trig functions based on the fact that cosine is now x and sine is now y. All right, so at 0 degrees, that's the first one we're going to look at. Sine at 0 degrees. So I go to 0 degrees, I look at the y value, it is 0. Okay, its reciprocal function is cosecant. So how do we do that? We take the reciprocal of the value. So 0 gets 1 over 0. That's the reciprocal of sine. And this is undefined because you cannot divide by 0. Okay, cosine at 0 degrees. If I look at 0 degrees, I will see cosine is 1 because remember it corresponds to the x value. So to find secant of 0 degrees, I take the reciprocal of it, which is 1 over 1, which is 1. Okay, moving on. Tangent. Tangent is defined as y over x, or sine over cosine. So if I look at that, sine over cosine, sine is 0, cosine is 1. That equals 0. Cotangent is the reciprocal function of tangent. So if we flip that over, we get 1 over 0, which is undefined. When we learn about the graphs of these, you're going to see that there are holes in the graph for cosecant and cotangent at 0. Part B. It asks us to do pi over 2. Pi over 2 is equivalent to 90 degrees. So we're going to do all 6 rather, at 90 degrees. So once again, for sine, you're looking at the y value at 90 degrees. The y value at 90 degrees is 1. its reciprocal at 90 degrees, we take 1 over the value, which is 1. Cosine at 90 degrees. Cosine is the x value. It is 0. Secant, what we're going to do is take the reciprocal of that, so it's 1 over 0. That is undefined. Tangent at 90 degrees. That is y over x, because it's sine over cosine. That's undefined. And cotangent at 90 degrees is going to be the reciprocal of that, so that is 0, because I can divide by 0. Okay, we've done B, now we have to do C. C asks us to find pi, which is equal to 180 degrees. So same process, we're going to look at the y value for sine, and at 180 degrees the y value is 0. Taking the reciprocal of that to find cosecant of 180 degrees is 1 over 0, which is undefined. Cosine of 180 degrees, we're going to look at